What's up, ladies and gentlemen? Assalamu alaikum warahmatullahi wabarakatuh. So today in this tutorial, I'm going to be showing you how to apply the windows on our structure. So let's give a fresh start. I'm just pressing Ctrl plus N, so I have a new file. Going inside the file, pressing next, 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 and this is our blank page. You can create your own structure, but I'm creating a very small structure, a simple one, by going like this. These are some dimensions. It is having 15 meters that is height, because that is relevant for the wind. And then I'm going to just transform this thing in our model. Yeah, it got transformed. Now quickly I'm going to just assign it certain actually this is cracker sounds because it's Diwali right now. That's the reason it's happening. So I'll just give it certain sections, like going for the defined, rectangular, so certain concrete sections, whatever some of the dimensions. We can give our own dimensions in the designing, but however this video is just dedicated to show you how to just apply the wind loads. Now I'm just gonna assign this thing, and then I'm going to give this supports, going for the front view and going for the supports, creating a fixed support. And all these things are completely just tentative, and you have to give it according to your choice. So assigning it to the selected node, assign yes, and then I'm going to go for the 3. Now our structure is ready. Now I just need to apply the wind load. So for applying the wind load, I'm going to go for the general or some definitions. In the definition, I'm going to go for wind definitions, clicking on add, and you can actually slow down this video so in order to see what exactly I'm doing. Or I'm doing a little bit faster because making the video a little bit short, so that you know, you will not get bored how exactly the things are going to be. So just adding the things, selecting it, again clicking on add. Now here is the main thing. You have to apply the intensity and the height at which that intensity of force has been applied. So for calculating that, I am going to use right now as Indian standards. You can actually use your own standards as well, but we need just two things: what is the force and what is the height at which that wind force is going to apply. So it's going to have a formula for calculating that. This is the formula: Vz is equal to Vb k1 k2 k3. This is IS 875-3987, a PDF where you can actually, on the Google, if you're going to type that, you'll get the thing free. Now we have certain factors here: Vz, k1, k2, k3, and all these things are completely theoretical. You can actually learn regarding this. You have completely information. Now I just give you a brief of what all these things are. The first and the foremost thing is this is the speed which we are going to use in our software. K1 is probability factor, and this is we have to calculate with the a table. It will be showing you where exactly you have to see. 5.3.1 will be going there shortly, and then another factor k2, another factor is k3. Now these three factors we have to use. Mostly these factors will be 1, but it's going to vary based on certain sometimes height. So how exactly we'll see. Probability factor, let's go for this thing. It's gonna be 5.3.1. Now based on the what kind of building, what kind of structure you're having, based on that we have to actually give that thing, and you can actually read that thing, and what category of building you are having, you can actually select that. So read these things carefully, and these are actually wind speeds. We're gonna get this wind speeds are actually based on which state we are living and where exactly we're doing the project, where the building is located actually. So if you can go downside, you will be having this factors. Like you can see on page number 53, you'll be having all different states in India, and you'll be having different factors for that. So for example, let's say Bhopal, we have 39. So these are the wind speeds wherever the building is located. You can actually select that state. And getting back to where we were, yeah, you can see the table is there, so that all the wind velocities will be listed here. So whatever wind velocities we are getting, based on that we have to actually take the factor, like coinciding this row and this row. So let's say I'm having all general building and I'm having the wind velocity as 39. I'm going to give the factor of k1 as 1, and next thing is k2. For the k2 we'll be having another table like this. Actually, K2 was not just a factor, it's factors. What is the meaning of terrain category? There are 4 terrain categories. You can actually learn this thing if you can see just beside that formula. These are different terrain categories. Just read them thoroughly to understand what exactly are these. Basically these are what are the obstacles we'll be getting. And then we'll be having ABC, what kind of building, what is exactly the width of the building to the height ratio, something like that. So if you want to learn about this ABC, what exactly is this ABC, you can actually learn that from here. Class A, class B, class C. And categorizing them, let's say I'm having this thing as my building factor, and then based on the heights we can actually take this values. So after going for K2 values, K3 value will be generally 1. It's actually the terrain. You'll be having the values for the K3 somewhere here. And then finally we have to get that VZ value. Let us say I'm having the things here. Vz is equal to Vb K1 K2 K3, and Vb is that wind velocities I showed in the last papers, like some 50s page number. And for calculating them, I'm just using my simple calculator. Let us say 39 multiplied by let us say 1.09 into 1 will give us this factor. So visit this formula 42.51. It's just some tentative things I'm doing, and you have to do according to your place, location, all that thing. Once that part is done, you have to use this formula for calculating actual PZ. So in order to calculate that, again getting back to my calc, and then what is the formula? 0.6, and now the value is actually 42.51. That is actually Vz square. So first I'm calculating Vz square. It means multiply by 42.51, it got squared, and then multiply by 0.6. So this is actually the value we'll be getting. So after getting these values, the next thing is we have to just apply that thing in the Staad Pro. So that's pretty much how you have to take the values and the heights as well. Now you can see here I'm having intensity as kilonewton per meter square. So first of all, you have to convert that meter per second to kilonewton per meter square. That intensity conversion, first of all, you have to do. So after converting, let us say I'm having the final value as, let us say 30, or let's start with the 20, and having height as 3, 25, 6, then let us say 30, 9. How we can get this different values? Because we have different K2 values. That's the reason we can get this different intensities. So okay, fine. 30, 35, let us say 12, and then 15, and then 40. Yeah, done. So I'm just adding this thing and then a factor. Usually this factor is because we will be having doors and windows in front, so that's the reason I'm just having this factor as, let's say, 0.9. Some losses will be happening. Wind pressure will not be exactly equal to normal, and with windows and doors, it's just like you just take a paper and blow blow air on this paper, and just put a hole on that paper and just again blow the air. So the paper in the first part, what I told you, will be having we'll be taking the more intensity as compared to the another paper, because it will be having hole and the air will be passing through that hole. So that's the reason some losses will be happening. That's the reason we added this factor. So just adding this factor to whole of the view everywhere, and then going for the load cases, click on add. You have to select wind, type it here, wind load, and obviously before that thing you have to add dead load and live load. So adding it up, wind load, add, and getting back to wind load, and then you can see we have windward direction, leeward direction. Windward direction is something from where the wind is coming, and leeward direction is exactly the opposite of it. Right now I'm just adding windward. Then I'm saying the range is going to be 3 to, or let us say 0 to 15. It means from the bottom to the top. And then I'm just going to click on add, and then click on close. And note that I'm just selecting here X, not Z, because I want to add in this direction and not in this direction. So whatever direction you want to add, you can actually add that thing. However, I think I did. Yeah, I did. You don't need to assign this thing. It automatically will be getting assigned. So once done, you have to just analyze that thing, and analyze will be pretty easy. Like what I'm doing, you can actually follow this step for analyzing, and that's pretty much. So done. Model's been analyzed, and you can see the reflection. So that's pretty much about today's tutorial, guys. Hope you like this thing, and if you have any doubt, you can actually WhatsApp me. You'll be finding my number in description. So till next video, if at all you want to have another video like this, you can actually comment me or message me on WhatsApp to get that tutorial. And my number is 8686498812. You'll get that thing in description box. Thank you for watching. Have a nice day. Bye.